Welcome back to Blue Pen Land here. Let's talk about viscosity. Viscosity is like the thickness of a fluid. Okay, some fluids are quite thick, some are flow rather rapidly. Right. The technical definition and the physics definition of viscosity is related to the area of this plate. Right. If we had a plate here that had a certain area, right, and we had a fluid separating that and a stationary plate, right? The viscosity is related to the force you need to exert to make it move at a particular velocity, right? With a certain thickness of the fluid, right? And basically that force is going to depend on, well, a lot of things, right? It seems like the faster you try to move it, the bigger that force would be, right? So I'll put velocity on the top. The more viscous the fluid is, the more that force would be, so I'll put that on the top. The more area that this plate has, it seems like that would be on the top, right? So let's see, we've taken care of area. Thickness. The thicker it is, I believe if it was really thin, it would be hard, and if it was really thick, it would be easier, right? So I think that's in the denominator, right? So we've taken care of that, the velocity, the area, the viscosity. Let's see if we got it right. Yeah, there we go. So there's the official approved formula, right? Okay, so it's the viscosity times the area times the velocity over, all of that's in the numerator, and then the thickness of this is in the denominator, okay? And let's just look at some viscosities here. These are the viscosity. Here's an interesting thing, right? A Pascal second is our unit of viscosity. And we'll look at how it's a Pascal second when we do an example problem, right? That is actually a unit of a Pascal second is actually 10 poises, okay, or it is 1,000 centipoises. So when you look up, if you Google the viscosities of different things, you'll see them in centipoises. Okay, here's the cool thing: if you look at the viscosity of air at 20 Celsius, right? Notice that it's almost exactly. I mean, I think the next digit is not a zero, right? But it's almost exactly 1 centipoise is the viscosity of water. Notice at 0, it's a little more viscous. At 100, it's less viscous, right? So if you've noticed that cold water soaks up into your towel a little more slowly than hot water, the viscosity has something to do with that, okay? I think there's other things, too, that have to do with that. Notice that, glycerin is, well, it's quite viscous, right? Corn syrup is something like 2,000 centipoises or 20 poises or something like that, right? Molasses ranges from like 8,000 to I think like 12,000 or something like that, right? This is like January, molasses in June or something like that. I don't know, right? It's slower than molasses in January. All right. I just can't hear you laughing. All right. All right. So let's go on. Let's just do an example problem of this. Okay. So a person slides a pan, right? So this pan it's maybe 45 centimeters long and 23 centimeters wide. And it's that overlapping area that matters, right? Over the surface of some molasses with a viscosity of 8.7 Pascal seconds or 8,700 centipoises or something like that, right? The molasses is 2.1 centimeters deep, and the person applies a pound of force. What speed will the pan move across the surface? So force is equal to what velocity times area times viscosity over the thickness. Did we miss anything? I don't think we did. Seems like we've got it, right? Okay, so the force is a pound, which is 4.45 newtons. Equals the velocity. The area is 0.23 meters by 0.45 meters. Right, the viscosity is 8.7, and that is, remember, a Pascal second is a Newton second per square meter. So I'm breaking it down. A Pascal is a Newton per square meter, right, times seconds. All right, and then we're going to divide by the thickness, which is 0.021 meters. I'm a little worried about the velocity. Where's the velocity? Oh, it's going to come out of the newtons, isn't it? Oh, that's crazy. All right, let's do the math. Let's figure out the units later. Okay, So 4.45 divided by 0.23 divided by 0.45 divided by 8.7 times 0.021 is, oh, it's in like scientific notation mode. It is, the velocity is 0.10378 meters per second. So that's pretty, right? That's thick. That fluid is thick. I'm exerting a pound of force, which is a considerable amount of force, and it's only moving about 10 centimeters per second. Let's just for a second, let's look at the units here. If you're totally uninterested in units, we can figure this out. You can just stop watching, but let's look at the units. So a Newton is a kilogram meter per second squared, right? Does that equal meters per second times, and then this is meters squared, right? Times newtons, so a kilogram meter per second squared times seconds divided by meters squared, all divided by meters. They go, oh my God, I don't even know. Okay, this meters squared cancels that one, right? Seconds cancels seconds, right? Meters cancels meters. Yeah, there we go. We end up with newtons equals newtons. All right. It's got a happy ending. I was going to expose the eternal flaw of physics. All right, good enough.